Hello, I'm Skip Metz at Rochester e-NABLE Labs, and I'd like to show you a new concept for a prosthetic arm that John Schul and I have been developing in the recent few days. We're pretty excited about it. And first I'll start with showing you the favorite arm for our favorite test pilot, Lucy. This is a casting of Lucy's residual arm. And this is the one she liked the best. It was a printed flat and thermoformed arm that was just padded with the sticky back foam that we've been using on hands forever. And you can see that unlike some of the arms we make, like the Team Unlimited arm, the opening is on the back, the elbow side of this arm, and it is thermoformed so that there's a tab that folds down around her elbow and another pair of tabs that fold down around the end of her arm. And it's just held in place with Velcro. And Lucy really likes this. She can use it with the gripper thumb without having to use the harness and cable and all that rigmarole. She just pops it on and off when she wants to. And of course it has a triceps cuff hinged to it that helps it stay on her arm. And we're replacing that, perhaps, with a new experimental idea. Instead of thermoprinting flat and thermoforming, we're using sheet plastic. And in this case, I've used polystyrene for prototyping, and probably will use polypropylene would be my favorite choice, maybe PETG. But here's a pattern for the cutout shape that ends up making a socket that looks like this. And the padding is just made from weather stripping foam with the sticky back. And it can be folded without thermoforming into a shape that's held together with Velcro. And again, there's a tab at the distal end of her arm that's folded over and held with another piece of Velcro. And you can see that that fits on her residual arm in much the same way as the favorite arm that was thermoformed. And yet, if all goes well, we can eliminate the need to do the thermoforming. And finally, the distal end of the arm is held together with Velcro again. And this is what we call the socket that goes next to the recipient's skin. And so you can kind of see how that fits. And because it's wrapped around the back side of her elbow and the front side of her elbow and held in place, it is really fairly sturdy on her residual arm. And then there's another piece that goes on top of this that is the actual arm. So we have a socket and an arm. And the arm part is also made out of thin, about 1/2 millimeter sheet plastic. And it is held together with a 3D printed plug that has a hex nut with a 1/2-20 thread. And that fits the standard prosthetics terminal devices. And it again is held in place with Velcro. So I held the end plug on with screws, and so this becomes this. And I've placed Velcro here and here. so that the arm fits over the socket, and it can be squeezed together and held in place with Velcro. And if you get it all adjusted just right, it fits pretty much like Lucy's favorite arm. And it's actually pretty sturdy. You'll see we can put the gripper thumb hand for a terminal device. So this is the way your elbow turns. And so it's fairly sturdy. You can see the gripper thumb works. And I'm just holding it by the casting. And it's pretty steady on our arm without even having the triceps cut. So the famous gripper thumb doesn't need a cable, but you can do two-handed task by placing the object into the gripper thumb with your unaffected hand. And one of the two-handed tasks we want to make sure that the user can do is to hold a fork to cut their food with a knife and fork. So that's it. We think this will be useful in places like Africa, Haiti, India, Nepal, where thermoforming might be difficult, where 3D printing might be difficult. The only printed parts are the plug on the end and the terminal device. And the rest can be flat sheets. We've got some more work to do to prove that it is strong enough to pass Jeff Aaronstone's stomp test. Jeff won't put a device on a patient if he can't stomp on it. If it breaks, he doesn't use it. So thank you very much. Again, this is Skip Metz at Rochester e-NABLE Labs. The design developed with John Schul and myself. Thank you.